The AEC sector is rapidly moving to the cloud. BIM projects are created, coordinated, and updated there. But producing 2D documentation still breaks that connection. ARES Commander keeps the BIM model alive and your documentation in sync, through every change, every update, every correction. It doesn't matter if the model was created in Revit or any other tool that uses RVT or IFC. If the model changes, we can easily reload and update it, which in turn allows us to update all project drawings, as we'll see in a moment. Once the project is stored in the cloud, whether in Google Drive, Dropbox, Autodesk Forma, or another platform, we gain access to online automation features. We'll look at these options in a moment. A dashboard will allow us to monitor the scheduled tasks. In this video, we'll follow the weekly workflow of a building project and explore how keeping a live connection to the BIM model transforms documentation workflows. We'll see how a single click can generate complete drawing sets, floor plans, sections, elevations, and sheets, both locally and in the cloud. From there, each discipline adds details, annotations, and expertise while preserving the live BIM connection. When the architect publishes a new model version on Friday, BIM Reload can automatically update every drawing over the weekend, ensuring everything is ready by Monday without losing any added work. We'll also look at advanced customization options, from modifying the appearance of BIM-generated drawings to creating filters, schedules, and data tables. Architects, engineers, designers, site supervisors, and even investors, all connected and synchronized through DWG-based collaboration enriched with BIM information. Let's get started. Every BIM project created with ARES Commander starts with a new drawing based on a dedicated BIM template. This template can be customized by the company to include predefined settings such as dimension styles, text styles, annotation scales, etc. None of this is new for a CAD user. When starting a new BIM drawing, the BIM Navigator opens automatically, allowing us to import BIM models in RVT format from Revit 2011 to 2026, or IFC files. Before importing, the program asks us to save the drawing. We can choose to save it locally or directly in the cloud, depending on the workflow we need. Although storing it in the cloud is important, because it opens up a new range of tools that we will look at in a moment. First, let's make an example with Revit files saved locally on our computer. If the project is split into separate architecture, structure, or MEP models, we can import them all at once and assign the corresponding discipline to each one. With ARES 2027, multidisciplinary BIM projects can be managed in an integrated way. For example, we can combine an architectural RVT model with a structural IFC model, regardless of whether they come from Revit, Archicad, Allplan, or any other BIM platform. We can choose which model we want to work with, either by turning models on and off or simply by removing them from the navigator. Once the models are loaded and coordinated, ARES Commander is ready to automatically generate project drawings directly from the BIM models. Now comes the moment that eliminates weeks of manual work. With a single command, BIM Auto All, ARES Commander automatically generates the complete documentation package directly from the BIM model. The BIM Automation Settings dialog allows us to define several parameters, including the default sheet size used to create the scaled views. We can also select a predefined material file, introduced last year in ARES Commander, which allows us to control the graphic appearance of BIM elements. Different disciplines can be combined into the same documentation workflow. We can also choose exactly which BIM categories should be visible, as well as define which floor plans, elevations, and sections will be generated. Everything ready? Then let the automation begin. In the navigator, we can follow the entire process as the views are automatically created and grouped by category, followed by the generation of sheets with their corresponding scaled views already placed and organized. Each one organized into sheet sets with title blocks, ready for printing. Labels and dimensions are added automatically. Grid lines from the BIM model are displayed. Do you already have drawings created in AutoCAD that you would like to reuse? such as construction details? No problem. You can simply copy and paste that content directly into the sheet. Does it contain dynamic blocks? That is not a problem either, since ARES fully recognizes them and preserves all their parameters and behavior. We can also take advantage of the more than 400 dynamic blocks available through the tool palettes, intelligently organized into different categories for a faster and more efficient workflow. Most of them are dynamic blocks, and some, like this example, also include attributes. The sheet structure works just like any traditional DWG project, where sheets display model space drawings through viewports. The sheet we are viewing contains this viewport, which we can open independently to work directly on it in model space. By creating dedicated layers, we can insert equipment and symbols using blocks stored in our tool palettes. Once the changes have been saved, all sheets containing this view will need to be updated. An icon and notification bubble will indicate which sheets require updating. The Trinity block library provides a wide range of pre-installed blocks, while also allowing users to upload and share their own blocks with colleagues. It also includes dynamic blocks organized into folders, ready to be inserted either in model space or directly into pre-configured sheets. Need a new block? Besides creating one with traditional methods, you can also use a 3. With a simple text prompt, you can quickly generate the missing block you need. In this way, we enrich the automatically generated drawings derived from the BIM model by adding new content on top of them. The previous example demonstrates a local workflow. Even though the file is stored in the cloud, the drawing extraction process is performed locally, and the result is then saved back to the cloud. However, there is a more modern and efficient way to work. It also requires less effort from the user. ARES Commander now allows tasks to be automated in the cloud. This means that servers can perform operations that previously had to run locally, freeing up the user's computer to continue working. For example, from the Cloud Storage panel we can right-click on a Revit RVT or IFC file, even if it is stored in Autodesk format. The available online automation options depend on the type of file selected. In this case, since it is a BIM file, we have 3 available options. The first one is the one we are interested in right now. By selecting it, we can extract the drawings just as we previously did locally. In addition, we can also request automatic PDF generation. The dialog box allows us to define sheet types, view scales, and other parameters. Most importantly, this task can later run automatically as a recurring process, but we will come back to that in a moment. What matters now is that we can execute the task immediately and let the servers process it, or schedule it for a specific day and time. The key difference compared to the previous workflow is that before, we used BIM AutoAll locally to generate all drawings, while here the process runs as a cloud task, with the servers generating the drawings automatically. This frees up your computer so you can continue working on other tasks while the extraction is being completed. When the process is executed locally, the generated files can be saved either locally or to the cloud. However, when the task runs entirely online, all generated files are automatically saved to the cloud. The Automation Job Status palette allows us to track completed and pending tasks. At the same time, it can also be opened in a web browser for a more convenient experience. As you can see, this is the Drawings Automation Job section of ARES Kudo. Once the task is complete, we can use this icon to open the location where the generated files have been stored. Even with ARES Kudo open in the browser, we can simply click on any of the drawings to view the result. We can even perform certain tasks within ARES Kudo related to BIM entities, which we will look at in a moment. From ARES Commander, once the task is completed, we can open the project. We can do this directly from the Cloud Storage palette. By opening the main drawing, We gain access to the pre-configured sheets with scaled views, or we can open each view independently to continue enriching the drawings by adding construction details, blocks, annotations, and additional content, exactly as shown in the previous example. As we saw a moment ago, ARES Kudo allows us to access the Automation Jobs panel, where all tasks are organized in a drop-down menu. By selecting a similar task, we can choose the RVT file and define the parameters just as we previously did in ARES Commander. We choose where the generated drawings will be stored, and we can even create new directories. Once the process is completed, the generated project can be opened either in ARES Kudo or in ARES Commander, just as shown in the previous example. But what happens when the BIM model changes? Sooner or later, the BIM model will change. Different scenarios may require reloading the BIM model in order to update the automatic drawings. One possible case, although becoming less common, is when a user works with a new model version stored locally. In this situation, ARES Commander allows the model to be reloaded easily, updating all drawings while preserving everything that has been added on top of the automatic documentation. Once the reference BIM model has been updated, the user simply needs to click an icon to regenerate all automatic drawings. A dialog box also provides options for automatically adjusting labels. Since this is a local process, we must wait for the machine to complete the update. The required time depends on the model complexity, the number of drawings to regenerate, and of course, the available hardware. With the new update, some of the elements we previously added may need to be adjusted, for example, adding or repositioning furniture. As the building evolves, the drawings evolve with it. Another scenario involves users working directly from the cloud. If the project was initially developed locally, it can be uploaded to the cloud, where a dialog asks whether to include all external references created during the initial drawing extraction. Once hosted in the cloud, ARES Commander allows the creation of an automatic reload task, defining the updated RVT source and configuring the required parameters. The regenerated drawings are stored in the same project location, while all annotations, blocks, details, and other CAD work remain intact. One key advantage of cloud workflows is always working with the latest model version, as the BIM file is continuously updated. Once the task is completed, we can open the result both from ARES Commander and ARES Kudo and continue working on the project. A third scenario is the possibility of updating an existing project directly from ARES Kudo by creating a background automation task. As we have already seen, the resulting project can later be reviewed either in ARES Kudo or ARES Commander, allowing users to continue enriching the drawings or correcting entities added during previous stages. One of the most important advantages of automatic drawings is the possibility of scheduling these processes, both from ARES Commander and ARES Kudo. For example, imagine a workflow where every Friday a new set of updated drawings must be generated automatically. This means that while architects and engineers continue working throughout the week on the BIM model stored in Autodesk Forma, or any other cloud platform, the project documentation remains continuously updated. An advanced user may prefer to build upon the automatically generated drawings by adding more customized content, such as additional views of the BIM model. To do this, simply return to the main drawing that contains the imported BIM model and generate new views. For example, you can create a section view by specifying its direction. After assigning a name, the view is automatically added to the BIM navigator. Following the same process, we can create as many views as needed, whether sections, elevations, or floor plan views for other levels, simply by starting from the appropriate elevation view. Now, let's go back to the layout where we want to insert the section we created. Right-clicking the view reveals several options. In this case, we select Place on Sheet to add the viewport to the sheet. Before placing it, however, we right-click once more to choose the appropriate scale. This view remains linked to the BIM model. If the model is updated in the future and those changes affect the view, it will update automatically as well. As in previous examples, you can add extra content on top of the generated view using blocks or standard CAD entities. BIM annotations are added automatically. In addition to drawings, we can extract data from the BIM model, for example, to create schedules. At this point, we are working on the second floor, so we return to the main 3D model. Here, we create filters to display only the second floor level. For this, under Criteria, we define Level, and then simply select the one we want to keep. Let's adjust the 3D view. Let's save this filter with a name. We then add additional criteria to show only the carpentry. To do this, we select Category, search for doors and windows in the available options, and add them. We save this new filter, which includes only the doors and windows from level 2. We could create all possible filter combinations to view each level with its corresponding elements, enabling even more complex views. If the drawing is stored in the cloud, data extraction is one of the tasks we can automate. This is especially useful when we need to extract large amounts of data from a BIM model. In this case, the data is very specific, so the process will be relatively fast. Data extraction is performed through a dialog box that guides each step of the process. In this example, we select in the drawing what we want to include in the table. BIM entities contain a large amount of data, as they form a complex database. Therefore, it is important to be familiar with the available categories and data in order to select only what is truly needed. At the end of the process, the software allows us to either insert the full content into a table or export it, or even do both at the same time. Once the table is inserted, we can simply cut and paste it into the desired sheet. This table can also be updated if the BIM model changes. Material Mapper gives users control over key graphical aspects of technical drawings. In this example, the hatched area of the wall, indicated with a diagonal pattern, is controlled by this BIM material, which currently has a specific 2D mapping assigned. We're going to assign a different one. Next, we need to apply the mapping to the drawing using this icon. The changes won't be visible until we update the drawing, either individually or all at once. Now let's see how to modify the graphical representation of a material mapping. In this case, it's the one currently named Concrete Structural. To do this, we open the BIM Material Library, where we can control the appearance of each material. For example, let's change the hatch scale, line weight, and color. We save the changes. To apply them, we simply reapply the mapping and update the drawings. Material Mapper gives you full control over the graphical representation of your mapped materials. By saving these settings as JSON files, you can easily reuse them in other projects or use them as a starting point for future work, reducing the need for manual adjustments. As we previously saved this project in the cloud, we can easily share the project with our colleagues. In this case, we'll ask a colleague to help us complete the furniture and equipment layout before sending the drawing to the client for approval. Our colleague receives an email notification because we mentioned her in the comment, allowing her to access the drawing directly. She chooses to open it in ARES Kudo and replies to our message. Perfect. She'll take care of the furniture and equipment layout. There are many ways to share the DWG drawings generated from the BIM model. For example, once the sheets are fully configured, we can publish the entire sheet set as a PDF directly from the sheet set manager. We could also package the complete project, including all external references, using Pack and Go, allowing another colleague to open it on their own computer. But there's an even more efficient option. Using automation, We can schedule the generation of a new drawing set every Friday evening and save it directly to the cloud. This way, site teams can start every Monday with immediate access to the latest documentation. And so, the automation task is configured. Meanwhile, Andrea is making the final adjustments. As we update the drawings, her changes appear automatically because the project is built using external references. Once everything has been reviewed, we could send the drawings to print, or better yet, share the drawing directly with our client using a view-only link for validation. Anyone can view the drawing through the view-only link without signing in. They can also use comments and markups for free to share feedback and validation if they sign in to create a free Graebert account. And there it is, great news. The design has been approved. From BIM-driven drawings and automated publishing to cloud collaboration and client validation, ARES Commander brings local and cloud automation together in a single connected workflow, now including direct integration with Autodesk Forma, that was previously known as Autodesk Construction Cloud.